In this Educated video, I want to show you why we even care about this form that we call vertex form. So for the past 2 days, we've been working with quadratics in standard form, and we've been rewriting them in what we call vertex form. Because some of you may be asking yourself, why do we even care about this other form? We've been working with these quadratics in standard form. We were able to solve these in standard form. We were able to graph these in standard form. So why do we care about putting these functions in some other form? Isn't that just busy work? It doesn't really seem like it's necessary. It seems like it's just making something that was easy into something more complex than it has to be. But today I'm going to show you that when we have quadratics in vertex form, it's much easier to pull information from graphs when our quadratic is in this form. Because I want to be honest with you guys, in the real world, you don't just have a pile of numbers like we give you in mathematics and we say solve. In the real world, you have functions that represent something with meaning, something in context. And when you guys get to future science classes and into college, you're going to have to pull information from those graphs. And it's much easier to pull information from these functions and from graphs when your functions are in vertex form and not standard form. That is why we are converting these functions from standard form to vertex form. Now, if you didn't quite understand what I just said, that's okay. We're going to look at a few examples. So all of you should have a worksheet titled Homework 11, and if you don't finish this worksheet in class today, I expect you to finish it tonight and to turn it in tomorrow before class. That homework assignment is due tomorrow before class. But before we do the first problem on the homework, on homework number 11, I want to go through one more example of rewriting a function that I have given you in in standard form, and we want to convert this over to vertex form. So take a moment. Right now, look at this function, look at the entire function, and tell me what is wrong with the function as it sits right now. Yeah, so really there's nothing wrong with this function, but if we're going to rewrite this function in vertex form, we look here and we say there's a problem here. This too is causing a problem because we know if we want to go from standard form to vertex form, we need to complete the square. But before we can complete the square, we need to have a 1 in front of our squared variable term. Now I call this the squared variable term because this x here doesn't always have to be an x. Sometimes this x could be an a, or a z, or a v, or a b. Now here it is x, so I find the coefficient of my x squared, and I ask myself, is the coefficient 1? And it is not in this case. So our first task is we need to try to get rid of this 2. And there's several different ways that we can do that, and most of you are just going to want to divide every single term by 2 to make sure that we get a 1 in front of our x squared. And yeah, that would work. It's not the best method, and the method that I want you to use is one that incorporates factoring. So we've been factoring since January, so hopefully you're starting to pick up on the idea and you're starting to understand what it means to factor. Now, let's see if we can solve this problem. Let's see if we can get a 1 in front of this x squared by factoring. So I'm going to rewrite the expression. We're going to have y is equal to, and I'm going to rewrite my expression, 2x squared plus 12x, and we'll do plus 19. Now what I'm going to do is I'm going to group the first 2 terms together. So this is very similar to one of the questions that you had on your last test where I asked you to factor by grouping. So I have grouped the first 2 terms together, and I want to factor something out of this expression, out of the expression that I've grouped, to make sure that I get a 1 in front of my squared variable. So what do you think? What do I need to factor out of this group to get a 1 in front of my squared variable? So hopefully you were able to say that we need to factor out a 2 from this expression. Now if you said 2x, okay, you're getting confused with what we did before where I asked you to factor out the greatest common factor. So the greatest common factor of the part that is in the parentheses here would be 2x. And if I asked you to factor out the greatest common factor, you would factor out a 2x, but I'm not asking you to factor out a 2x. I'm asking you just to factor out something that will make this coefficient 1. And in this case, In this case, the number is 2. We want to factor out a 2 to get a 1 in front of that x squared variable. So go ahead. I'm going to put my open parentheses, and I want you to tell me, okay, to figure out what I need to put right here, my first term inside the parentheses, what do I need to do? Yeah, so to figure out what the first term inside the parentheses is going to be, I need to divide my first term up here by whatever it is that I'm factoring out. So in this case, I'm factoring out a 2, so I want to divide my first term by 2. So you can kind of see here what it looks like. Okay, it looks like that I am pulling a 2 outside of this expression in front of the parentheses. And whenever you pull that 2 outside in front of the parentheses, you have to divide each term inside the parentheses by whatever it is that you're factoring out. So to get my first term, I need to do 2x squared, which is this term, and I need to divide it by 2 because that is what I'm factoring out. If I were factoring out a 3 out here, I would divide this by 3. If I were factoring out a 4, I would divide this by 4. So I do 2x squared divided by 2. We know that 2 over 2 cancels out, and I'm left with x squared. So my first term inside the parentheses will be x squared, and then I divide my second term. So my second term here is 12x, and I want to divide this by 2 to find out what my second term inside the parentheses will be. So I do 12x divided by 2 is equal to, I do 12 divided by 2, that gives me 6. Now this is a problem that I've seen a lot of you make, a mistake that I've seen a lot of you do on your tests and on your homeworks. When you divide 12 by 2, yes, that gives you 6, but a lot of you forget to carry your variable over. Don't forget, just because you do 12 divided by 2 to get 6 doesn't mean that that variable just disappears. So don't forget to carry that variable over with your 6. So inside my parentheses, I'm going to get plus 6x, close parentheses, plus 19. Now at this point you can see that we're getting closer. We're almost getting there to vertex form, but we're not quite there yet. Before we can get this into vertex form, we need to complete the square. So the part that is inside parentheses, we need to complete the square, which is perfectly fine to do now because we have a 1 in front of our x squared variable. So I'm going to rewrite this expression. Y is equal to 2x squared plus 6x plus something, okay, plus something, and I'm going to leave a gap, plus 19. So you tell me, what do I need to add inside these parentheses to make all of this inside the parentheses, so these 3 terms, a perfect square trinomial? So you tell me, what do I need to add right here to complete the square? Yeah, so hopefully you were able to see that we have a 6 in front of our x. We always go to this number, the coefficient in front of our x, and we half it and square it. So half of 6, that'd be 6 divided by 2, and we square it. So 6 divided by 2, that's 3, 3 squared, that's going to give me 9. And that tells me what I need to add inside here to complete this square. So this tells me I need to add a 9. So I add 9. And now we have a perfect square trinomial inside the parentheses. But this is not okay. We can't just add terms willy-nilly, just as long as we like to. We can't just add numbers to an equation without correcting for it, because this equation is no longer, the way it's written right now, it's no longer the same as what we started with. So now we need to correct for this. So we added something, so we need to subtract something from this expression. So what do you think? What do we need to subtract right here to correct for this 9 that we added inside the parentheses? So a lot of you were probably able to say that, or a lot of you probably said that we need to subtract 9, but that is not correct. We don't need to subtract 9 here. Now, had we started off with an expression that had a 1 in front of our squared, or our x squared, that would be okay, but we didn't. We did not start off with a 1 in front of our x squared variable. We factored out a 2. So really, we're not adding 9 when we put a 9 in here. We're actually adding a 2 times 9. Okay, a 2 times 9. So 2 times 9, that's 18. So really we need to subtract 18 out here to make sure that this stays a balanced equation. Now, if you don't understand this, go back and watch the video from yesterday, the second video from yesterday, and walk through another example and make sure that you understand this. And if you don't, then be sure to come in for tutoring tomorrow afternoon and ask me about this. So at this point, it's pretty much straightforward to solve. We know that this is a perfect square, so we can factor this using that trick that I taught you. So we get y equals 2, and we know we can factor this by just writing it out in this general form. So what do you think? If I want to factor this perfect square trinomial, what do I need to add inside the parentheses to factor this part of the expression? So hopefully at this point you were able to say, so we look at the coefficient of x and we just half it. Okay, we've got positive 6 divided by 2 and we get positive 3. If this were a negative 6, I'd do negative 6 divided by 2 and that would be negative 3. So we half this number and that goes here to factor it. We half that number and square it, that's what we did over here, to find out what we need to add to complete the square. So now we have factored this expression. That's what this is. So this x plus 3 squared is the same as x squared plus 6x plus 9. Now, we just bring our constants down. We'll go ahead and combine those. So negative 18 plus 19, that's just going to give me plus 1. So now we have taken a function that we have in standard form, and we have rewritten it in vertex form. So this is my final answer if your goal is to write a function in standard form into in vertex form. So go ahead and continue with the next EduCanon video, and please email me if you have any questions. And notice, this is exactly the same function as number 1 on your worksheet. But go ahead and stop now and go to your next EduCanon video.